first law. First law is this. It can be written differently. You can write it like this, minus P delta V. As far as using the first law explicitly, I would say for just about any class, it's almost a plug and chug. So you'll know it's this kind of problem if they note the internal energy, or there's other terms for it if you're in different classes, but if they note this term, it's probably going to be this type of problem. It can come in a few different forms. One form, and let's just make sure we got our signs right. Which way would Q go to be endothermic? In. So it's positive or endothermic. Same for work. How do we term work going into the system?
Work done on the system.
Usually work done on the system or something like that. If work went the other way out and being negative, it would be
By the system.
usually by the system or something very similar to that. So first make sure you got your signs, and then it could just be a word problem, putting in Q and W, finding delta U. A couple other problems like this. You'll notice, and we'll get to this in a second, delta H, there's several ways to find delta H. Two of them that you mentioned are Hess's law of delta H of formation. You'll notice for any given reaction, really, we should be finding delta U, or the internal energy, the overall energy. However, in a constant pressure system, work, it approaches zero compared to the other terms. So it turns out that delta U is approximately equal to delta H. So for reactions and anything we do in chemistry, we're talking about delta H. So that's why we've always found ways to determine delta H. There are some examples where we would give you delta H for a reaction, give you the work for a reaction, and you find delta U, the overall term. So technically, the energy given for the overall reaction, or the heat of reaction, really I should say the energy of reaction, would be delta U. We're assuming that's equal to delta H. It doesn't have to be. So, if we give you the energy for reaction and talk about work, we want to use the whole equation. If that happens for reaction, really for work, where you could use this, you would more likely want to use the other half of the ideal gas law. Like that. So let's say an example reaction. I'll just make something up. A gas plus B solid goes to C liquid plus D gas. Let me balance this. 2, 3, 5, 4. Let's say it balances like that. Okay, so delta N would equal, what's the first term and then minus the second term? What's the first?
9 minus.
Not 9. 4. You don't count liquids. That's not a gas. You can't go in the ideal gas law. 4 minus 2, because that's only gas over here. 4 minus 2, so that'd be positive 2. Okay? Let's just think about that. Would the work be, so a gas is being formed. Just forget the sign here for a moment. Forget that. Just think about it. If you have gas formed, is the system doing work or is work being done on the system? Yeah, if a gas is being formed, it's pushing outwards into the surroundings. So the system is doing work. And so that should be, the W term should be positive or negative in this case? Negative. So the negative you see here is correct. Okay, it should be negative overall. So you can always rethink through, make sure the term sounds right. By the way, let's just get this down. R would be what number? Yeah, this number, because you want it in joules, because energy terms are typically in joules, or thermodynamic terms. And then the temperature would be in kelvins, whatever temperature is given. Okay, so if the work term was relevant, that would mean it would be mentioned, something about the work, and you do a calculation like this one right here, and you put that into the W part of the calculation. If it's something like that, delta U would be given, you'd find W, and then you'd solve for Q, which would be delta H. Okay, so that's a different style of problem. Otherwise, it just goes straight in. Sometimes a question will just ask about work, and so it'll be one of these two equations. How do you tell if it's the top equation that should be used? You just have pressure and volume. And you know it's the bottom one if you have temperature but not pressure and volume. That's it. Okay? In this case, what would the units of work be if they give you pressure and volume? Liters atmosphere, so you would need to convert to joules, and I presume if your instructor is like me, they may or may not be, they will give you the conversion to joules on the back of the exam. Okay. Okay. Any quick questions about this before I move on to other things in thermo? Again, you can ask me specific questions starting around 9 o'clock. All right. Gone. Next. Let's do some calorimeter action. Let me make up a problem. It'll work. It'll work. Okay. Let's say we have water here. T initial is 25. No. Let's say it's 80 degrees C. Let's say I have metal here. It's really hot. Let's say T initial is 10,000 Kelvin. You're going to put this in here. Okay? So you're dropping the metal in. The water is going to warm up until it starts to boil. Okay? So the water is going to warm up until it starts to boil. I want to know how much boils. Okay? So if you put it in, it's going to warm up. It's going to start to boil. You want to know how much boils. Okay. And let's say there's, I don't know, I'm not writing anything right now, so you can chill. I get it. It's fuzzy. I get it. 950 milliliters. Okay. All right. So let's try to set up this problem at least. You can solve it at home. I just made it up, so I don't know if the numbers will work, but we can see how you can set it up. All right. So how I set these up, if you're not in my class, I go to sum of the q's equals 0, and then I list all q's. There's two sources for q. One source of q is temperature changes, and the other source of q is more generally than a phase change, more general.
Enthalpy.
An enthalpy change. Yeah, and a phase change is a type of enthalpy change, which is here. You could also have a reaction or a delta H of solution. Any delta H also has a Q. So, are there anything that changes temperature? If so, what is it?
The metal and
The water. Anything else?
the metal.
Yeah, you could say the calorimeter. Anything else change temperature?
The metal.
Yeah, the metal should cool down. Anything else? All right. Is there any delta H terms? Yeah, for vaporization, I told you it would start to boil. So Q for boiling. Okay? All right. So all three of these terms will be an MCP delta T. This term will be an N delta H term. Okay? Anything that has to do with enthalpy, which would be a phase change, a reaction, or a delta H of solution, are the three categories you should see in Chem 2B. All right, let's talk about the four different terms. All right, Q, water, let's start there. M, CP, delta T. Let's talk about delta T first. Delta T would be, what's T final? 100. Yeah, it goes to boiling. What's initial? 80. That's what I told you. CP is a constant, 4.184 joules gram degree C. Should be on the back of your exam as a constant that's given. How do I find the mass? Let me zoom out a little. Yeah, the mass is not given, which is normal, but notice the volume's given, so you'd have to use density times volume. Density, yeah, it's on the back of my test, or you know it, 1 gram per milliliter, and multiply by 150 milliliters. All right, let's talk about some of the other terms. How about Q-cal? If I don't give you the heat capacity of the calorimeter, you would do what? Yeah, you say it's negligible. You're assuming it does not contribute. Okay, let's talk about Q, the metal now. The metal is mCp delta T. Delta T, what's T final? Yeah, 100. It has to cool down to boiling. Okay, so it cools down to boiling. Initial, what did I say? It was ridiculous. 10,000, okay. I have something's kind of weird here though. Yeah, this is in Kelvin, so I technically should subtract 273 to change it to Celsius. Okay. I would, oh, this is the arrow. Also, M, and, that's and, CP has to be given. I just made it up, so I don't have those, but those would have to be given. Okay, so you would have the mass of the metal and the CP of the metal would have to be given. Let's talk about now the last Q, the Q of boiling. I'll do it like this because you go copy. Okay. Q of boiling equals N delta H. That'd be a pretty generic way to write an enthalpy Q. What delta H is this? Delta H of, what's the subscript?
Vaporization.
Yeah, delta H of vaporization. Let's think about this. Would this be a positive or negative number if it's going from a liquid to a gas? It's boiling. Positive. You got to put energy in to boil anything. That's why you boil water, pour noodles. You have to put heat into it. So I know this is positive. You've got to be careful on the exam. This can be true for anybody's exam. We'll just give you a delta H for the vaporization, but the sign may not be right. So you need to make sure you have to think about the correct sign. So typically it would be given, in this case, for vaporization. So if we were condensing, you'd have to know to think it's and put it to a minus sign. Is that okay? You always got to think about the delta H term. It's not necessarily as it's written. All right. What's the N term? That's moles of, yeah, moles of water. That should be, what, why, did I give you this number? What is it? We got to think about it. So this is the amount that is boiled. So this is what I'm looking for. I want to know how much water boils. Is that okay? Do you get the general setup? Are there any questions? I'm not solving it because I made up the numbers. I don't know if it works. Yes?
So after the boil,
you do not have to have a Q for condensation because the problem didn't say it would condense. It's just saying it's boiling. And as I stated before I started, it's boiling, but it's not saying that it all boils and then jump beyond that. If it all boiled and continued to heat up, you need another Q for the temperature change of steam to the final temperature. But definitely not going the reverse direction. Okay? All right. Next. I'll just do a little bit on delta H of formation. A couple things I want to do here. First, one, you should know, three things I guess. One, you should be able to write the reaction of a formation of something, whatever that something is. So for example, NH3, so if you're forming it, it would be the product. We'd have to give you the state, so let's say it was a gas. So it's formed from elemental form. Students in other classes, you should know what elemental form is. If you don't, I guess I'll show you just in case your instructor mentioned it, or you didn't mention it, or you forgot, whatever happened. Let me flip over to my reader. It'll fix itself in a second. Okay. So you need to know what elemental form is. All of these have enthalpy of formations of 0. That's assumed knowledge. So it's assumed that if you see these in the correct state, that you'll know that it has enthalpy of formation of 0. My class doesn't give it. I'd be surprised if other classes give this. It's just assumed knowledge. So the enthalpy of formation is a formation from its elemental, how it's found, form, to whatever is asked for. So it'd be this. So I'm going to use N2 and H2 gas. N2 gas plus H2 gas will form this. This has to, let's go a different color. This has to be, oh wow, that's really zoomed in. Okay, this has to be a 1 here. So then you need to balance accordingly. If this is a 1, this would be a half. That's a 1, this would be 3 halves. So this is the delta H of formation reaction for ammonia. So that should be writable for you. The other thing is, given any particular reaction, you should be able to, I'm not sure if somebody said question or not. So let's say it was a reaction like this. Let's balance it. 1, 2, 1, 2, 3, 4, 2. Another thing, given any given reaction, you should be able to find the delta H. Given, and the givens I'll write in purple, given the delta H of formation for this, and for this. Okay? So why would this delta H of formation not be given? Yeah, it's 0, so that's something you would need to recognize by yourself. So the delta H would be the delta H, with big parentheses here, formation of CO2 times, there's 1 of them, plus delta H of formation of H2O, and there's 2 of those. Big minus, open parentheses, delta H of formation of CH4, and there's 1 of those. I'm not including O2 because it's going to be 0 anyways. So we would expect you to set up a calculation like this, products minus reactants, and find the answer. It can be written in different ways. We could give you this number and ask you for one of these, for example, but same idea. All right. Any questions on that before I go to Hess? Yes? Oh yeah, that's a good question. Okay. We could do 2 things depending on what kind of fun we want to have in the question. So either, the question is where is delta H given? Either it's given in the question itself, if we want to be super nice. If we want to have a little fun with you, we'll give it on the back of the exam. So these delta H's could be given on the back. So if you don't see them and you need them, look on the back. What I would recommend when you're starting the problem, when you're starting the exam, take 20 seconds to stare at the back page and see if there's anything unusual there or just what's available for you. And then get started. Or maybe write down a couple things you think you might forget and then kind of get started with the exam. That's where you would see if we give you weird values like this. Sometimes you do that, it just depends. All right, ready for Hess's Law? My class, have we done this one? Yeah. Oh, we did? Yeah. Ah. We did that one. Did we do This one? Ah. Okay, oh, I got it. Well, this one that you can't see, did we do it? I'm zooming out, so it takes time. I don't want you to see the answer, so I have to zoom out slow. Because the answer's written at the bottom, I'm trying to cover it up. Well, that sounds easy to cover the paper, but I don't cover the paper. There we go. Did we do this one? Yeah. Yeah, it's full in the front row. Okay, let's try this. We're going to find the delta H. You know it's Hess law, we give you a lot of reactions. Feel free to take a picture of this so you don't have to waste your time writing it. Alright, so what you're going to do, I have two strategies if you're in my class. Strategy one is to compare the overall reaction with the simultaneous. And I want to find things that appear twice and only twice. So, 1, 2, 3, 4. Which one would I pick? Would I pick one? Is this, yeah, this is good. It appears here and here. So, this number 2 simultaneous has to match the first top reaction. So I will multiply by negative 1/2, right? Minus means it flips, and 1/2 will mean there's one of them in the reactant. So this will multiply by minus 1/2. All right, next, would I pick CO? No, there's too many of them. Would I put this one, FeO? Yes, that will work. So I'll put a brown box around it. All right. So what would I multiply this by? 3. Negative, because I'm not flipping. I'm trying not to show the answer. Okay, here we go. So, minus 3. All right. Finally, CO2 looks like garbage, right? Because it appears too often. So my last step is, second part of the strategy is to look at intermediates and see what would appears only twice. So first of all, is iron an intermediate?
Yes.
Yeah. Is it a good choice? Oh, I was going to say yes. Yeah, it only appears twice, here and here, right? So if it appears twice, that's a pick. Now, unlike the ones in the overall reaction, the intermediate has to cancel. Uh-oh. Oh yeah, no, it's good. We're good. So, this one is fixed. I can't change this minus 3. So, what will I multiply this first one by? Okay, minus 3 over 2. That'll make this minus 3, and this one's minus 3. Those will cancel. So minus 3 over 2. So you're going to multiply these through and add them up. Or if you're like me, you type the answer at the bottom. Okay? So there we go. Any questions on this? Pretty classic question. I would say this is medium difficult, but pretty normal to see on an exam. Questions? Okay, I'm going to look at what's next if you're still typing or whatever you're up to. I don't know. Writing. Oh yes, I know what we're going to do next while you're thinking. Are you ready? Can I move this?
Yeah.
Okay, you got like 10 seconds. I'm going to go on to solutions now. There's only one topic I've covered so far, so we're just going to do that one topic. Okay. For other classes, this can be written differently, but for my class, this is classic, and it's literally from an exam, but an exam that's not, I believe, not in your practice exam reader. Okay? It's similar to those because there's only so many ways to write them, but It's just an example. It's also different, written differently than the one I did in class. We're going to take a picture so you don't have to write all this garbage down. Okay? All right. So, yeah, and you should be familiar with these types of concentration units. All right. The ethanol water solution is prepared by dissolving. So we've got ethanol. I'll just call it E. For ethanol, that's got 10 milliliters. Producing output solution. We've got 100 milliliters. So it added water. So ethanol would be considered the solute. We added the solvent water, and we've got so much solution. And we know a couple other things. The density is 0.789 grams per milliliter, and density here is 0.982 grams per milliliter. All right. First of all, what's the difference between those two densities besides the numbers? The top one is what kind of density? It's just for ethanol. Just for ethanol. The bottom one is the whole solution. Okay? So it includes the solvent and solution. I know this one is just for ethanol because it's listed after ethanol. So it doesn't have to say that specifically. If it's listed after it literally, then that's what it means. This one, if it's either listed after the solution and or says solution density, then it's the solution density. Let me ask you a question. Is the volume of water 90?
No.
Not necessarily. Why not? What do we know about water and ethanol? They have what between them? There we go. Hydrogen bonding. So it's going to contract. And so that's why we have to give you the densities. Okay. So the only easy part about this question is going to be the first part, the volume percent. Volume percent is the volume of the solute, 10, divided by the total, 100. This is the only easy part, 10%. Okay, the rest you actually have to think. All right, so let's do this. I recommend finding the mass and moles of everything you can, and then do all the calculations. That's my style of doing this, so let's try that together. Okay, so let's start with ethanol. Ethanol, we've got 10. So to find its mass, how would you do that? Yeah, use the density, that's right. Those of you who mumbled that are correct. Oops, I put the wrong side on the bottom. Milliliters, 0.789 grams. This will give you the mass of ethanol. Wish I would have calculated that number. I guess it's just 10 times this. 7.89 grams. Okay? Now, what other mass am I going to find? Yeah, let's do the mass of the solution. That's an easy one. 100 milliliters times the density, just like before, 982 grams per milliliter. So the mass of the solution equals, I guess, just 98.2 grams. What if I wanted, in case I wanted the mass of the water, the solvent, how would I find that? Yeah, this you can subtract. So the masses you can add and subtract, but you can't do that with the volumes. Okay? So the mass of the water, I'll put W, is just 98.2 grams minus 7.89 grams. I didn't find that ahead of time, so if somebody wants to calculate that, I'll write it down happily. Wow. In her head. 90. I hope you're on point like she is for the exam. Way to go. 90.31. What will I also find for the mass of the water besides just grams? Kilograms. I'll find moles in a second. I have 1 kilogram. Why is that? Molality. Yeah, so this also is 0.09031 kilograms. I'll need that for the molality. Okay. Now, like other people mumble, I do need the moles of everything. So let's do that action. So, the moles of the ethanol would be 7.89. How am I going to find that? Periodic table, molar mass. Do they give that in the question? No, unfortunately. It would be about 24 plus 6 plus 16. Is that 46? Okay, it's about 46. Okay, math savant in the front row. That number is? 46.0? That sounds off. That was not my original person. 172. Okay? Alright, that's the moles of the ethanol. I also want the moles of the water. The moles of the water would be the mass. That was 90.31 grams. Molar mass of water is 18.02 about grams per mole. And that is?
5.017.
Okay, 5.02 about. Alright, I've got the moles of the water. I think I've got about everything I need right now. So now let's go for everything first. Now I'm going to do my calculations. Mass percent is the mass of the ethanol divided by the total mass, 98.2 grams, multiplied by 100. Math savant, is that 8.03%? Okay, I'll assume that's right. Next, what was asked for? The mole fraction. That's X. That is the moles, 0.172 divided by total moles. Math savant, I got 0.033 in my mind. Okay, cool, I'll go with that. Polarity. Molarity is the moles, 0.172 moles, divided by the volume. What do I put in the denominator? 0.1, is that what we said? You guess? I mean, I have to believe somebody. Is that, how did you get that? I like this number. No, I think I know what the answer is. It's going to be 1.72 or 1.71. Where's this number from? I like this number.
The total.
Yeah, it was the total volume originally, 100 milliliters or 0.1 liters. Finally, molality, lowercase m, is the moles divided by the kilograms of the solvent, which was, wow, what was that?
0.09031.
9031? Yeah. I got 1.89 molar. Molal, actually. All right. If you're in other classes, this question could come in the form of a multiple choice, say, where it's just, we give you one unit, you convert to the other. In my class, it's coming like this. By the way, in my class, let me give you typically the way we grade this problem. Let me just type out the numbers, okay? We'll give you typically 1 point for the correct units and 2 points for the correct answer. So, if you put a blank here for units, that's good, that should give you a point. That's how this works. I want lowercase m here, uppercase m here. I want percentages there. You see how that works? And then the numbers better be right. Okay. Normality, capital N, was not asked here, but if it was, it would be the same as molarity because we don't have an acid here, or a base, really. So it'd be the same number as the molarity. Okay. Any other questions on this problem?